Allogenic stem cell transplantation is a high-risk procedure usually done to increase chances of curing a number of blood cancers, including leukemia. Now, to tell us more about this method is Dr. Daniel Fowler, a tenured senior investigator in the Experimental Transplantation and Immunology Branch Center for Cancer Research of the National Institutes of Health in Bethesda, Maryland, USA. Good morning, doctor.
Thank you.
So the U.S. government sent you down here, is that correct?
That's right.
Tell us more about that.
Well, it started about 10 years ago. We had a patient that we were trying to bring to the NIH to do a stem cell transplant. His name was Irwin, and unfortunately we weren't able to bring him here. He died. But his sister's a doctor here, and she started a foundation, Leukemia Foundation.
All right.
And it's the first leukemia foundation here in the Philippines.
Oh, fantastic.
And that's why I'm here for this trip, to meet with them, to see if we can collaborate more, and to teach them about the way we're doing transplant and how it may help their efforts here in the Philippines.
That's great. Well, what have you, so far, what have you been keeping busy with since arriving in Manila?
Well, we did a little touring of the history, and then since then we've had a series of lectures at the hospitals here and with the medical students and the doctors.
Tell us about allogenic stem cell transplantation.
Well, it's complicated because it has a long history of being used initially to treat radiation injury. That was the initial concept.
Right.
If there's a lethal amount of radiation, then you could give a stem cells from another individual. That's what the allogeneic means. And that would repopulate the blood system.
Okay.
And the initial idea in leukemia treatment was, well, we could get rid of the leukemia by giving a lot of treatment and then bring in these new stem cells to repair the patient after the curative therapy. But what really emerged over the last 20 years is a new understanding that it's more the immune system that can cure the cancers rather than the high doses of chemo and the radiation. So really the conceptual change with allogeneic stem cell transplant is to focus more on the immune system.
And also because people have not really known much about leukemia and the other options that they might have within their reach in terms of treatment, because chemotherapy for leukemia is very expensive. And someone once told me before that you would have to be in remission first before you actually get treatment for leukemia, but now things are changing? Yes.
Traditionally, well, anything you do, if you start with a low bar, if everyone's in remission, then you're going to have a higher success rate. So as we get better at doing transplant, then we would hope to extend to patients that are in remission, but also even now we have patients who have progressive disease. They're actually cancers increasing at the time of transplant, and we've had success in many of those cases as well.
So it sounds very technical, but how does this allogenic stem cell transplantation work? So you were explaining to me allogenic meaning someone else, not your own.
So the donor, whether that's a brother or sister or other family member.
That's compatible?
Compatibility in terms of the genetics is good if there's a certain amount of matching. There's never a perfect match. Perfect match would be an identical twin.
Which I don't have, which not many people have.
Very few do. And in fact, in those cases, the transplant doesn't work as well because there's no genetic disparity. It's actually the disparity in the immune system that causes the recognition of things as foreign, and then the attack can occur against the cancer. So you want some disparity. And as we get better at doing the transplant, we can take increasing disparities. So you don't need a so-called perfect match.
Okay. Now, are there complexities or risks to this form of transplantation?
Yes. The initial way of doing transplant using the high-dose chemotherapy and radiation, that's called myeloablative transplant, has a lot of risks and usually was only acceptable for younger patients. As we get older, what's the definition of that? Well, it could be 35 or 50.
The age bracket on that.
Yeah. So that's a relative term, but now what I'm getting involved in is this area called reduced intensity transplant, where we use lower and lower amounts of chemotherapy before the transplant.
I don't know much about this. So how are the stem cells collected?
Most stem cells now are collected through the peripheral bloodstream of the donor.
Okay.
So the donor gets 5 days of different shots, and then the cells are collected in a blood bank.
Okay. So it's
about a half a day
painless?
Yes,
Yeah.
it's relatively painless, and many of us in the field also believe it's better for the patient because we can get a higher quality of stem cells, a higher number. And also when we do the collection, there's a lot of immune cells in the collection as well, those important cells that can recognize the leukemia as foreign.
Right now it's not available in the Philippines, correct? And that is what you're trying to...
Yeah, I did a lot of research on the medical websites before I came here, and
those big quotes.
I was shocked to see that there were very few transplants being done here for a country of 100 million people. I realized over the history of the Philippines, only about 100 people have received an allogeneic transplant. Just from my own calculations, every year for a country this size, there should be many thousands of people each year receiving a transplant if it was used in the context that we use it in the United States.
If any of our viewers who are in the medical field want to be part of the lecture you might be holding, how do they get in touch with you or your team?
Yeah, they could contact the Leukemia Foundation here in the Philippines, the EPCALM, EPCALM Foundation.
Okay. We're very lucky to have you here this morning to share all this with us, and for you in the country as well. And I do wish you all the best in your endeavor, and thank you so much for stopping by the show this morning. Thank you for being here, Doctor.
All right.
That was Dr. Daniel Fowler from the National Institutes of Health in Maryland, USA.